So right now I'm walking up into the hills of Berkeley because there's a grove of trees that I think is really pretty, and I want to use that grove as a backdrop for a video about anastomosis. Maximus talks about biology. Anastomosis. Anastomosis is a word about branching. There are two ways that a structure can branch. It can ramify or it can anastomose. Ramifications are what trees do or river deltas do. You've got a trunk and it branches, and then the branches branch, and then the branches branch, and then the branches branch, and you get this boop, 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 boop kind of structure. Anastomosis is the opposite of that, so it's when branches fuse. So I've made a little tree here that illustrates both of those branching patterns. Up on the top, the trunk ramifies. So you can see how the branches split. There's a branch point here, and here, and here. And so each time that splitting occurs, you get a separation. On the other side, the roots aren't ramifying, they're anastomosing. So you can see it's not really clear where the beginning of a branch point is and where the end is. You just get this muddled network where everything is attached to everything else. So that's anastomosis. Why is anastomosis important? In high school biology class, you're taught that the tree of life only splits. Life started as a single universal ancestor at the base of the trunk, and then it split. And all of the beauty and diversity of life comes from these speciation events, these branching points. But of course, it's not that simple, because the tree of life also contains anastomosis events. Look over here, you see this lichen? Lichen is a funny kind of organism because it's a symbiotic merger of an alga and a fungus. Lichen grows in extreme places, like on the bark of a tree where there's not much water or nutrients. The way it works is that the alga takes energy from the light and transforms it into sugar. But the alga can't do it alone, because the bark of a tree is a very hostile place to live. So it lives inside of a fungus. The fungus secretes enzymes which digest parts of the bark, but it doesn't get any energy from the bark, just minerals. It gives those minerals to the alga, so the alga can make more sugars, and then both the alga and the fungus feed on the sugars that are created. The alga and the fungus are completely codependent on one another, so dependent that we don't consider them unique organisms. They're the same creature. But they weren't always the same creature. There was a time millions of years ago when there were free-living alga in the seas and free-living fungus in the mud. They have their own unique evolutionary origin and history, but at some point those histories fused and they became one thing. This is very, very important. Evolution is often taught in schools as if it's all about competition. Survival of the fittest, nature red in tooth and claw. But in actuality, that competitive narrative is more indicative of the capitalist society that evolutionary theory has developed in than it is indicative of the natural world at large. The tree of life is riddled with anastomosis events. And in fact, these points of fusion are the most important locations on the tree of life. 800 million years ago, there were no trees, there were no lichens, there were no people. There were only tiny unicellular organisms swimming around in a primordial soup. But then something changed. Those organisms figured out a way to extend the boundaries of themselves beyond themselves. They fused and became the multicellular creatures that we know today. Anastomosis shows us that the story of the tree of life can be told in terms of cooperation instead of competition. Life's branches don't branch in isolation, and they often fuse back together. Thanks for watching. And remember that everything and nothing are actually intertwined. So it's nighttime, right? And you hop into the dumpster with your flashlights and you're scanning through and you're ruffling through all this trash, and there's tomatoes and there's avocados